This is what archaeologists see: a prehistoric excavation, dirt mounds, and building ruins. This is the World Heritage Site of Catalhyk in central Anatolia, Turkey, the home of a long-time archaeological excavation of a Neolithic neighborhood. The catalhyk research project pioneered many of the standard practices of 3D archaeology, a process that digitizes artifacts, rooms, and even entire excavation sites. The catalhyk archaeologists built an extensive database of information collected at the site, with 3D image recordings of the most important artifacts. We used this database to develop a virtual reality that could preserve and give access to catalhyk from any laboratory, classroom, or museum. When we first enter the catalhyk digital simulation, what we see is based on the current site and its available data. With a touch of a button, we can go back in time to when this was a bustling farming community. We can visualize houses, neighborhoods, and the surrounding landscape. Outside, we see animals grazing on the grass. We can even interact with the livestock. Looking around more, we see household objects, also produced from the catalhyk digital archaeology database. Everything that we see in this virtual world is what we think catalhyk must have looked like in the height of its civilization. But how can we really know what it looked like? This full model of the city is an extrapolation, drawn from the archaeologist's imagination, built on assumptions and informed interpretations of what was found in the dirt starting in the 1960s with the first excavation. As the archaeologists at catalhyk learned more, their interpretations of the data developed and changed. Our digital 3D model of catalhyk shows us in a concrete way what happens if we change our assumptions about what the data means. For instance, we can change the details of the visualization. Perhaps the user will adjust the indoor ceiling height. As the ceiling moves up and down, other aspects of the virtual environment would be affected, like the density of smoke in the room, how the room could be used, and how many people it could have held. The user can experiment with where doors and windows are located, and where cave paintings are drawn, or whether the landscape undulated, always with the goal of better understanding how life was lived there. This 3D simulation shows the direct consequences of different interpretations of this prehistoric world, helping us compare theories and enliven archaeological debate as we highlight and play with our assumptions without destroying data, traveling to Turkey, or getting covered in dirt. This tool brings catalhyk findings to life, communicating and testing them in a way a photograph, pottery shards, or an illustration just can't achieve. Being virtually inside the ancient world you study, and being able to adjust details based on your theories about how life functioned there, helps you start to understand catalhyk Turkey in a new way. The creators of this tool, at the Center for Mind and Culture in Boston, and at the Virginia Modeling, Analysis, and Simulation Center, want the simulation to be both true to archaeological data and clear about the interpretive process of visualizing catalhyk as it was. We want users to experience the interaction between hard data, what we know, and rational assumptions, what we conclude about what we know. Archaeology brings us into direct contact with the everyday technologies, housing structures, art, and societies of prehistoric people. It broadens our understanding of ourselves and our past beyond what is written in history books. This interactive 3D simulation of the world discovered at catalhyk invites us to step into history and make our own conclusions.